refraction. Okay. Now, why we study refraction? Because optical fiber works on the principle of total internal reflection. So first of all, we discussed reflection, which is we covered in the previous lecture. But in this lecture, we discussed refraction, then total internal reflection, and how optical fiber works on that particular principle. Okay, this is our today agenda. Okay, in this class, we discussed refraction and some idea of total internal reflection, then MCQ related on particular topic. Okay, this is our today class. Suresh, okay, sir. Okay. See, what is the refraction? First of all, see, we consider an example. Okay, now need to study that particular point. Okay, see me carefully. This is our surface. Okay, or we can say transparent medium. This. Okay. This is the plane which deviate or diverts all the medium in two particular region. This is the incident ray like that, and this is the normal. And what is normal? What is incident ray? This is we discussed in the previous lecture. See, this is the incident ray. Okay. If this light bounce back in the same medium, or we can say bending of light in the same medium, then this phenomena is said to be reflection. This is we discussed in the previous class. Okay. Now, if this rays, incident rays, move or propagates from one medium to another medium, then it deviates from its path, or we can say bending of light in the different medium is said to be refraction of light. Okay. See, this is the normal. This light either bends towards the normal or away from the normal. This is depends on the optical densities of the medium, or we can say refractive index. What is the refractive index? N equal to C upon V. That is the speed of light in a vacuum upon speed of light in a particular medium. Okay, this is we discussed in our previous lecture. Okay, so either this this is the incident ray, this is the normal, this is the transparent medium, and this is the refracted ray. And the angle between the incident ray and the normal is the angle of incidence, same as we studied in the reflection. Okay, and this is the angle between the refracted ray and the normal. This is said to be angle of refraction. Okay, not angle of reflection. Okay, see, if this ray partially bending in the same media, then this phenomena is the partially reflection and partially refraction. But in today's lecture, we only discussed refraction phenomena, because in previous lecture we studied the reflection. See, so either this refracted rays bend towards the medium, bend towards the normal or away from the normal. How we can say, and what is the condition on which this situation occurs, or we can say on which conditions refracted rays bend towards the normal or away from the normal, we study in that particular lecture. Okay, and this is said to be Snell's law. Okay, see, one by one. What is refraction? Refraction is the bending or change in direction of a light ray when it passes from one transparent medium to another, because its speed changes. Next, light does not change its frequency when entering another medium. Only speed and wavelength change, and that cause bending. What is the relation between the speed of light in a medium and wavelength and frequency? See, speed equal to distance upon time. Okay, and 1 upon t is the frequency and d is the lambda. Okay, lambda f. So speed means speed v, and this is the light. So here we consider c equal to lambda f or f lambda, this, and f equal to c upon lambda. When This is the very important properties of the light. Okay, when light travels from one medium to another medium, then c and lambda, that is the speed of light and lambda, okay, change proportionality. That's why f equal to c by lambda. When c and lambda change proportionally, then a frequency of the medium remains same. This is the basic important property. Okay, now this is the beta, this is the point. This is we explain like that. Next example, एयर से वाटर, ठीक है, एयर टू वाटर रेज ट्रेवल कर रही है, ओके, एयर टू ग्लास, वाटर टू ग्लास, दैट इज वाई, ओके, दिस इज द एप्लीकेशन ऑफ रिफ्रैक्शन, या दिस इज द एप्लीकेशन ऑफ रिफ्रैक्शन. up to that, up to this point we explain the refraction basic phenomena. Up to here any doubt? Are you understand the meaning of refraction? HP, Suresh, Azmira, tell me. Okay, okay guys, okay. Next, this is the example when light rays travels from air to water, air to glass, water to glass, and that is why a straw in a glass of water look bent. Okay, this is the example of refraction. A swimming pool appears shallower. Lens, spectacles, cameras and microscope work. Okay, why does light bend? ठीक है, this is the why does light bend. Light travels with different speed in a different media. How? See, c n equal to c upon v, okay, and v equal to c upon v. N equal to, this is the n equal to c upon v, okay, n equal to c upon v, okay, n equal to c upon v. So here we write v equal to c by n. See, if any medium having the higher refractive index, then when we divide it by c by n, then we get the lower speed. That's why, because every medium composition, or we can say optical density of every medium is different. That's why light travels with different speed. With the help of this formula, you understand easily. Okay, v equal to c by n, and n, that is the refractive index. This is not the basic meaning how much amount light deviates from its path, or how much amounts light as compared to light of speed of light, the speed of in any medium reduces. Okay, this is depends on the refractive index or optical densities. See, medium, speed of light, and medium, vacuum. In vacuum we consider light approximately 3 into 10 to the power 8 meter per second. This is the maximum value. Air slightly less. How slightly less? Because for air, see, vacuum having the refractive index approximately 1 or exactly 1. Only vacuum is a non-magnetic material. Okay, so for vacuum refractive index is 1, but for air refractive index, tell me anyone, what is the refractive index for air? Tell me anyone. Okay, no idea. Sarvagya, Suresh. Okay, no problem, yaar. See, for air approximately 1.003, or this is approximately 1 na. This is approximately 1. This is the sign of approximation. See, that's why when we find the speed of light in air as compared to vacuum, so put when we find the speed of light in air, then put in place of n 1.0003 and in place of c 3 into 10 to the power 8. Okay, then we get slightly less than c speed, means we get speed in air of light slightly less than 3 into 10 to the power 8, because this n for air is approximately 1. Okay, now water. For water, refractive index is approximately 1.33. And beta, for refractive index means refractive index is a ratio of two speeds. So refractive index does not have any unit. Okay, because c upon v na, speed cancel out, unit cancel out. So this is the ratio, and ratios are unitless in general. Not all ratios are unitless. Okay, but this ratio is unitless because this is the ratio of the same physical quantities, speed and speed. That's why units cancel out and refractive index does not have any unit. Okay, next. So if we find the speed of light in water, then use this formula, v equal to c upon n. C is the 3 into 10 to the power 8 and n equal to 1.33. Then we get the slower speed. Okay, now again glass. But a glass normally depends on the material used in the glass. On the basis of material, glass offers different refractive index. But here we assume flint type glass, and for flint type glass, refractive index is approximately 1.52 normally, if not given. And no need to remember all the refractive index. You only remember for air, vacuum, water, and ice and diamond. These are very, very important. Okay, see, refractive index of glass is approximately 1.52. Okay, and for ice 1.31, for diamond 2.42. Okay, this is we discussed in the next slide. We write is okay. For diamond refractive index 2.42, for ice 1.31. Only these 5 or 6 examples are important for your examination. Okay, when we put here, if we want to find speed of light in a glass, then we put in place of n 1.52, then we get even slower as compared to water also, because glass having the refractive index higher than the water. If we want to determine the speed of light in a diamond, and diamond having the refractive index 2.42, when we put here 2.42 in place of n, then we get speed even slower than the glass also. Okay, because diamond having the highest refractive index in the given example. Okay, but this is clear or not? How much? So here we can say refractive index indicates the optical densities of the medium, or we can say how much times speed reduced as compared to speed of light. This is clear or not? Tell me. If this is clear, then thumbs up so that we understand. Tell me, beta. This is clear, na? How speed and refractive index depends in a different medium. Mukund. Okay. Good. Next. This is the basic funda for finding the speed in a different media. This is the basic introduction of refraction here. Now, when light enters a denser medium, optically denser, not a water density and ice density compare. Okay, optical density, denser means related to optical densities. Okay, when light enters a denser medium, that is optically denser, it slows down and bend towards the normal. When light enters rarer medium, it speeds up and bends away from the normal. Important terms. And this is 2 points we discuss with the help of an example in the next slide. Okay, wait. We consider some terms as we discuss in the reflection also. बट ये जो हिंदी मीडियम वाले स्टूडेंट हैं, क्या ये समझ में आ रहा है आपको? ज्यादा डिफिकल्ट तो नहीं लग रहा ना? अगर कोई भी बच्चा, केवल यही लाइन में बोल रहा हूं, कोई भी स्टूडेंट यहाँ हिंदी मीडियम का है, वो हिंदी में आसानी से समझ सकता है, तो मैं बाद में टॉपिक समझाकर उसे समराइज कर सकता हूं। लेकिन कोई भी बच्चा अगर इंग्लिश मीडियम में है, तो मैं एक तरह से दोनों यार बैलेंस लेकर चल रहा हूं, पूछ लेना मुझसे, ठीक है? यहां सारी चीजें आपको समझ में आनी चाहिए, मेन फंडा वो है। ओके, नाउ वी मूव फॉरवर्ड। मुकुंद, ओके ओके ओके, ठीक। नाउ दिस इज द बेसिक टर्म्स, consider that this is the transparent medium, like that. This is the incident ray. Okay, this is the normal, this is the point of incidence. See, first of all, incident ray, incoming light ray, this is the incident ray. Next, refracted ray, this is the refracted ray. Here we consider denser medium. Okay, now how light bends we discuss in the next slide. Okay, here we discuss the terminology used. Next, normal, imaginary perpendicular line at the point of incidence. This is the points of incident and this is the imaginary perpendicular line is said to be normal, and all the angles measured from the normal. Okay, next, angle of incident, that is I, angle between the incident ray, this is the incident ray, and the normal, and this is the normal, this is the angle of incidence. Okay, this is clear, and this is also written as theta 1. Okay, or theta I, I or I equal to theta I. We also represented I as theta I in our next course. Next, angle of refraction, that is small r, angle between the refracted ray and the normal. This is the normal, this is the refracted ray, this is the angle of refraction. R also written as theta r. Okay, this symbol we also used in our next course. Next. Now beta, this incident ray, refracted ray, normal, angle of incident, angle of refraction, these all are clear or not? Okay, if any student facing any type difficulty, then please discuss with me and use the audio feature. Okay, not chat, audio feature use. Okay, next, laws of refraction, or we can say Snell's law. This is the very important is Snell's law. See, what is the Snell's law? We explain with the help of an example. See beta, this is the any transparent medium. See, okay, in simple words, simple. This is the incident ray. Okay, incident ray. This is the point of incidence. Okay, and this is the normal, and this is the normal.
सर एक क्वेश्चन था।
Yes beta.
सर जैसे कोई इंसिडेंट रे एयर से वाटर में जाती है तो वो उसकी स्पीड कम हो जाती है। तो अगर मतलब जैसे कोई इंसिडेंट रे ग्लास से बाहर निकल रही हो तो उसकी स्पीड वापस से वही हो जाएगी एयर में, या फिर वो कम रहेगी?
अब वो डिपेंड हाँ, एयर में अगर जा रही है, यस बेटा, जैसे उसके रिफ्रैक्टिव इंडेक्स है ना, उसके हिसाब से वो चेंज होगी, बिल्कुल ठीक है।
मतलब सर उसकी स्पीड वापस से बढ़ जाएगी?
हाँ हाँ बिल्कुल बढ़ेगी यार, रिफ्रैक्टिव इंडेक्स के अकॉर्डिंग।
ओके सर।
आओ नेक्स्ट, सी दिस इज द नॉर्मल, this is the normal. Now, and here in this medium, refractive index is n1, and this is the angle theta I, or we can say I, incident angle, and we assume that n1, or we assume that n2 is greater than n1, means medium 2, this is the medium 1 and this is the medium 2, and here we consider a hypothetical case that medium 2 having higher refractive index. Higher refractive index means this is the denser medium. Denser or rarer medium is defined in terms of optical densities, or we can say refractive index. Here we assume a hypothetical case in which medium 2 having higher refractive index as compared to medium 1. Okay, when light travels rarer to or we can say one medium to another medium, or we can say lesser denser medium to higher denser medium, then refracted ray bends towards the normal. This is the basic principle of refraction, then this light bends towards this normal. If we assume another case, okay, if we assume n1 greater than n2, means n2 less than n1, then we can say light enters from denser to rarer medium, and this refracted ray move, or we can say bend away from the normals. Okay, these are the 2 points we discussed in this, but this is the 2 points. Okay, next, this is the clear. When light enters a denser medium, enters a denser medium, optically denser, it slow down and bend towards the normal. When light enters a rarer medium, it speed up, bends away from the normal. This is the basic laws of the reflection. Now see, and this is the angle of reflection R. Okay. Now, how we can apply Snell's law? See, how we can apply. See, in the medium 1, refractive index is N1. Okay. What is the incident angle? Sine of incident angle, that is sin I, equal to, in the different medium, refractive index is N2, and the sine, cosine, see beta, and the sine of refracted angle. These all are equal, means the multiplication of refractive index and the sine of incident angle is equal to multiplication of refractive index of the second medium and sine of refracted angle. These are the Snell's law. Okay. Now, how we can explain theoretically? This is the mathematical explanation, and according to this procedure, we explain how much angle is required for total internal reflection in our next slide. Okay, see. First law, the incident ray and the refracted ray and the normal at the point of incident all lies in the same plane. This is similar to reflection. Next, this is simply means refraction is a 2D phenomena, not twisting out of the pages. Okay, means bending of light occurs in the same dimension. See, second law, Snell's law. For a given pair of media, the ratio of sine of angle of incident to sine of angle refraction is constant. Means sin I upon sin R equal to constant, and this constant is said to be refractive index. Okay, means relative refractive index. See, next slide. This constant is called the refractive index, n equal to sin I upon sin R. Okay. Okay, this is the beta, but you understand easily mathematically this concept. Okay, this is the relative refractive index. Okay, we explain in the next slide in better way. Okay, now we consider refractive index mu or n. Both are the symbol of refractive index. Absolute refractive index n equal to c upon v. Okay, c is the speed of light, 3 into 10 to the power 8 meter per second. V is the speed of light in the medium, and larger refractive index, slower the light, optically denser medium. This is be clear. Okay, this is we discussed in our initial slide. Okay, glass having 1.52 approximately. Okay, refractive index, and when we put v equal to c upon, this is the v equal to c upon n. When we put n value, then we get lower the speed as compared to speed of light. Okay, next, relative refractive index, when light goes from medium 1 to medium 2. See, sin I upon sin R. Here we explain now, this is the relative refractive index. Then this is the our proper analysis, n2 upon n1 sin I upon sin R, or we can say n2 into sin R equal to n1 sin I. But basically, see, you only understand this concept here. Again, we explain. This is the incident ray, this is the normal. This is the refractive index n1, this medium having the refractive index, this is the medium 1, this is the 2. Okay, and here in medium 1, refractive index is n1, here refractive index n2. And we assume n2 is greater than n1 normally. Okay, then refracted ray bend like that. means bent towards the normal. Here incident angle I, here refractive angle is R. How we can explain the Snell's law and relative refractive index and all? See, in one medium refractive index and one angle of incidence, take sine of that angle, sine I, equal to in second medium refractive index N2 and multiply this refractive index sine of refractive angle, sine R. This is the Snell's law. Now beta please confirm me in the chat box, this is understand by you or not. ठीक है, if you understand by this concept then please thumbs up so that we understand. Based on density of medium refractive rays direction change. Yes beta Suresh, you are right. Anubhav Negi, beta this is clear or not? How we can apply Snell's law? No need to remember these relative and absolute and all. Only beta this we, if you are understand this concept then Snell's law is complete. This is now see this, when light travels from medium 1 to 2, okay, then beta this formula and this formula are same. See, n2 into sin r, n2 into sin r, n1 into sin I, both are equal. Okay, this is, but where beta this is easily understand. Okay, this approach in one medium refractive index n1 sin of I equal to in second medium n2 into sin of r. This is the basic approach. Now see, if we write this equation like that, now we move on the very important concept. See, this is the n2, this is the n1, means n1 is the refractive index of medium 1, n2 is the refractive index of n2. But see, if we assume that this is the water, and this is the diamond. See, water having refractive index 1.33 approximately and diamond having the refractive index 2.42. Here we assume a hypothetical case and this is the very important. See, so here we assume this is the water, this is the diamond. Okay, then when we apply this formula, so n2 2.42, that is the refractive index of diamond, n1 is the refractive index of water, that is 1.33. When we put putting the values of refractive index of diamond and water 2.42 and 1.33, then we get a constant value or variable value. Confirm me in the chat box or audio. If we put the refractive index of both the medium in this equation, or we can say in Snell's law, then we get a fixed value or variable value. Tell me. Constant. Pratibha, answer me. Constant. Yes beta, yes, constant. That's why the ratio of sin I and sin r is constant, because every medium having the fixed densities, optical densities, or we can say each medium having the a finite value of refractive index. That's why when we use Snell's law, n2 upon n1 or n1 upon n2, if we use sin r upon sin n, then we get n1 upon n2 when light travels from 1 to 2. Okay, see, then this value is fixed. That's why we explain like that. This point beta, the ratio of sine of angle of incidence to sine of angle of refraction is constant. That's why here we explain each and every point. That's why we use constant term. Okay, because the ratio of two refractive index are a fixed value or finite value or constant value. Okay, now Snell's law is clear or not? Tell me. Then when, if this is clear, then we move rays behavior in different cases. Here we beta two cases assume. If this is clear, then please confirm me so that we move forward. Okay, Suresh, this is clear na? Suresh, Pratibha, Azmira, Anubhav, HP, Sarvagya. Now see beta, See beta, if n2 upon now see that this point only discuss these things. See beta, if again we assume the same example. This is the water, this is the diamond. We're putting the value of n2 and n1 and we get a fixed value. See, okay. If we increase the value of I, if we increase the value of I means in angle of incidence, then what is the impact on refraction angle? Tell me, anyone? If we increase the angle of I, then what is the impact on refraction angle? Tell me. Reduces or increases? Tell me. Yes, increases. Yes, very good. Very good, HP. Suresh, yes, beta, yes. Because we maintain the ratio fixed. If we increase the value of I, consider if we put the value of I 30 degree, means this angle is 30 degree. If we bend like that, this, then this angle increases. When this angle increases, to maintain the ratio of refractive index fixed, okay, then this light like that, this is the refracted rays bend towards the normal or away from the normal when we increase the value of I. Tell me, when we increase the value of I like that, then this angle increases. Then what is the impact of this refracted ray? Bend towards the normal or away from the normal? Tell me. Tell me, anyone? One student, Azmira and HP, two words. Bend towards the normal. Okay, see? Beta, if we increase this I value, then if we bend this refracted ray like that towards the normal, then R increases or decreases? Decreases now. Then why you say this refracted ray bend towards the normal? Beta, if we increase the value of I, then R also increase now. Then why you say this refracted ray bend toward the normals? If this refracted ray bend toward the normal like that, then R increases or decreases? Decreases now. Okay, but this R decreases or increases? Increasing now. That's why this light ray bend towards the plane, or we can say away from the normal. That's why this angle R increases. Okay. Away to make value constant. Yes, Mukund. Tell me, Pratibha, Suresh. This is clear na? Tell me, beta. Okay, beta. If you not understand any points which can be discussed in the slide or in any point written as PPT format, or we can say written in the mathematical format or equation and all, you discuss with me na. Okay, see, this concept is clear or not? Tell me. When we increase the value of I, then this R also increase na. This is clear? If this is clear, then please thumbs up. If any student can't understand this concept, then discuss with me and come on the audio feature. Okay. Okay, beta. Then we conclude that. What we conclude? See, one by one. If we increase the value of I, then R also increase. This is clear. When we reduce the value of I, then R also reduce to make the ratio constant. This is clear? Okay. Now, if this I increases, see, if we consider an hypothetical case, this is the plane mirror and this is the medium one having the refractive index N1, this is the N2 and this is the incident ray, this is the angle of, this is the normal and this is the angle of refraction I. If we consider N2 greater than N1, same case, then it bend toward, if this is moved like that. See beta, if this is moved like that, what is the condition in which this incident ray does not deviate in the second medium? N1 greater than N2, or here we consider one question from your side. See, this is the medium N1, this is the medium N2. Then what is the relation between the N1 and N2? If this incident ray look like as this, means does not deviate in the second medium. Tell me. Yes, cherry. Cherry name है directly proposed. Yes, beta Suresh. Cherry, you are right. N1 equal to N2. This is good. Now, second case. If we consider N2 is greater than N1, then this bends. Okay, here we consider some point so that you understand easily. Here we consider the same. N1 is greater than, sorry, N1 is equal to N2. That's why this incident ray does not deviate. Then, what is the angle of refraction in that particular case? Tell me. If N1 equal to N2 and light travels look like this, then this is the I, this is the R. R is the angle of refraction made between the normal and the refracted ray. Then what is the relation between the I and R? Tell me, in that particular case. Yes, yes, you are right. I equal to R. Yes. Now, consider an example, another example. If any student facing any problem, then discuss with me. See here. If we consider another example, if this N2 greater than N1, then this refracted ray bend towards the normal. Then what is the relation between the I and R? Means I greater than R, I equal to R, or I less than R? Tell me. If the light travels from N1 to N2, means rarer to denser medium, then I greater than R, or I equal to R, or I less than R? Yes, I greater than R. Yes. Now, we consider another example. If this incident ray means light travels from rarer to denser medium, here we consider N1 greater than N2, or we can say N2 less than N1. Then light bends away from the normal like that, and this is the R. Then in this case, small r greater than I. Okay, this is clear now. Okay, beta. Now we discuss the two cases. Ray behavior in different cases. See, case 1, rare to denser. And here we consider example air to glass. Okay, so this is the example like that. This is the transparent medium. This is the incident ray. This is the normal. Okay, this is the medium 1. This is the medium 2. And here refractive index N1. Okay, here refractive index N2. And so light bend towards the normal like that. And this is the small I. Okay, and this is the small r. Now we consider the point. Small r is less than I, or we can say I greater than r. Okay, ray bend toward the normal. Okay, speed decreases. Okay, wavelength. How speed decreases? N equal to C upon V, V equal to C upon N. If any medium having the higher refractive index, then according to this refractive index, or according to N equal to C upon V formulas, speed R reduces. Okay, that's why we make the point speed reduces, wavelength decreases, because speed and wavelength both are proportional to each other, and frequency does not change. Frequency equal to speed upon wavelength. Speed and wavelength both proportionally change. That's why frequency remain constant. Now beta, this point, this point, this point, this point, this point, both points are clear or not? Tell me. Both points, 4 points are clear or not? Anubhav, HP, Azmira, Suresh, tell me beta. Any doubt? Tejasvi. Okay. Now next case, you easily understand. Case 2, denser to rarer means glass to air. Here we consider an example here. This is the incident ray, this is the normal, okay, this is the medium 1 and this is the medium 2. Here refractive index n1, here n2. Beta here we assume refractive index, okay, air to glass means air to denser means n2 greater than n1 na, n2 greater than n1, okay. Next, here glass to air, okay, this is n glass to air, n1 is greater than n2, okay, and here we mark, okay, yes, see, then this okay, glass to air, okay, this is move away from the normal like that, okay, this is the small r and this is the small I, okay, this is clear. Now small r greater than small I, ray bends away from the normal, speed increases, okay. How speed increases? Because this medium having the lesser refractive index as compared to one na, okay. Because glass to air, this is the glass and this is the air according to this particular case, okay. Now wavelength decreases and frequency remains same. These all points are clear. We mark here frequency remain same, okay. Here also frequency remain same, okay beta. Tell me, this is the all about basic of refraction yaar. If you understand these basic things, these two cases how are, then you easily understand the concept of total internal refraction, okay. Now see, important relation, frequency remain constant, this is we discussed in the previous class also. Special condition, if light falls perpendicularly like that, this is the medium, this is the incident ray, not this, perpendicularly na. If light like incident like that, then what is the normal? This is the incident point and perpendicular to this point we draw the hypothetical line, this is the normal, means normal and incident ray are coincident, okay. Now overlapping line, then what is the angle of angle of incidence? Zero na. What is the angle of incidence between the normal and incident ray? Both are overlapping to each other, then I equal to 0, okay. No bending occurs, only speed and wavelength changes, and this is the not very important theoretical point, only we discuss the small I is 0 in that particular cases. Now we discuss one example. If n1 equal to 1 and n2 equal to 2, this is the hypothetical case, not 2. Here we consider n1 equal to 1 and I equal to 30 degree and r equal to 60 degree, 60 degree, 60 degree, then find angle of refraction, okay, and figure is given as this, and this is the medium 1, this is the medium 2, okay. This is the incident ray like that, this is the normal, okay, this is the normal, and this angle is given at 30 degree, okay, and this angle is the 60 degree. 60 degree means angle greater than the 30 degree na, that's why we draw the refracted ray away from the normal. If we draw toward the normal, then r less than small I na. Here mention r equal to 60 degree, angle of refraction is 60 degree, that's why we draw like that. So this angle is the 60 degree and If n1 equal to I equal to this, then find no angle of reflection na. Then find angle of reflection is given na. Then find refractive index, refractive index of second medium, of second medium, that is n2. Okay, fine beta, try. What is the angle? Navneet Kumar, beta, are you having any doubt? Tell me. Navneet, tell me beta.
No,
If
sir. No, sir. No, sir.
if any student having any types of problem, then please go on audio feature and discuss with me. Okay? In any slide, theoretical or mathematical, any doubt, discuss with me on the audio feature. But this question we consider only for that. Here we want to know, you know the concept of Snell's law or not? 1 upon square root 3. Okay. See, अनुभव नेगी प्रगति प्रगति का आंसर 1.73. अनुभव नेगी 1 upon square root 3 means 1 upon root 3, that is the 0.56. See beta, how we apply the Snell's law in that particular question. See, we change the marker. Solution. See beta, see. What is the solution? In one medium, light travels medium 1 to 2. In one medium, refractive index is n1 into sine of angle of incidence I equal to, in second medium, refractive index n2 into sine of angle of refraction, that is small r, putting all the given values. But this is the Snell's law. If you not understand the concept of this, then please confirm me. We again explain the concept of Snell's law. If you understand this concept, then please thumbs up so that we understand the concept of your understandings. Tell me beta, this is clear na, Suresh? See, what is the n1 value? N1 is given 1. 1, okay. And sine I, incident angle is the 30 degree, okay, equal to n2. N2 is the unknown. Sine of r, what is the r? 60 degree given. Then what is the value of sine 30? 1 by 2. N2, what is the value of sine 60? Root 3 by 2. Okay, then n2 is equal to, n2 2 to cancel, n2 equal to 1 upon root 3. Okay, that is 1.73. Okay, this approximately, this is the not 1.73. 1 minute, 2 to cancel, n2 equal to 1 upon root 3. 1 upon root 3, not 1 upon 1.73 na. Root 3 is the 1.732. Okay, then 1 upon root 3, or we can say 1.73. This is the value 0.56, I think. Okay, verify. Not Suresh, 0.57 something आता है ना, 0.56 0.57 समथिंग आता है ये, ठीक है. दिस वैल्यू आर फेमस यार. रूट 3 1.73, रूट 2 1.414, 1 अपॉन रूट 2 0.707, 1 अपॉन रूट 3 0.57 समथिंग. ओके, दिस 4 values are very very important. Okay, now this is the rough work. Okay, now better tell me, how we can apply Snell's law? This is clear or not with this example? Azmira, why you write the 1.73 beta? Tell me, Azmira. One 1.73 is not the right answer, na? This is the value of root 3. I think you forget the taking the square root of that, na? Okay. Next, this is the basic problem. Types of refraction of light. But these are the basic point. Up to here, we discuss the two cases when light travels rarer to denser and vice versa. These all the same point here. We read out the fastly. Refraction of light is defined as the bending of light rays where the speed of light is different when it travels from one medium to another medium. Okay, there are two types of refraction of light from rarer to denser medium and vice versa. And this is the figure. Okay, this is the denser. Here we assume n1 is greater than n2. So this is the denser, this is the rare light, this is the incident ray. Okay, this is the angle of I, this is the angle of R, this is the refracted ray. Then small r is greater than I. This is we discussed in the previous slide also. And here we assume n1 less than n2 means rarer to denser. Okay, then this refracted ray bend toward the normal. This is basic thing. Denser to rare medium, rare to denser medium. लाइट ट्रेवलिंग फ्रॉम रेयर टू डेंसर क्या क्या होगा वो सारा हमने डिस्कस कर लिया है. ओके, दिस इज बी डिस्कस इन द प्रीवियस क्लास, प्रीवियस स्लाइड. ओके, म्यू डी अपॉन म्यू आर इक्वल टू कांस्टेंट. ओके, मींस refractive index in one medium to another medium is always constant, and this is the sin I upon sin R or Snell's law. Light traveling from denser to medium, this is we discussed also in the previous slide also. Okay, characteristics of refraction of light. What is the properties, okay, of the refraction? This is the last slide of today's lecture. Then we discuss the problems based on that particular topic. Okay, see. The following are the characteristics of refraction of light. All refractive surfaces obey the laws of refraction of light. Okay. Or a ray of light bends when it, yeah, a basic point. Okay. This is we discussed in the previous class. Na? A ray of light bends when it travels from one optical medium to another with different refractive index. When light passes from a denser medium to rarer medium, then refracted ray bends towards the normal. When light ray passes through the rarer medium to denser medium, the refracted ray bends away from the normal. The speed of the light decreases in the denser medium. The speed of light increases in the rarer medium. The frequency of light does not change when it travels from one medium to another medium, but velocity and speed of the light medium to another. But the velocity and speed of the light changes. Okay, frequency does not change. Now, beta, these are the same point. Na? Tell me, in any point you face any difficulty? Tell me beta. This is clear. Okay, if read by yourself, if you facing any difficulty in any point, then please tell me. Clear na? All points are clear or not? This is the summary of the refraction, yaar. This is the summary. Anubhav Negi, clear, sir. Okay, my dear. Next. Now this is the question for you. Light enters from air to glass with a refractive index this. Okay, means second refractive index of glass given hai. What is the speed of light in the glass? Try. Tell me, beta. Speed of light in the glass. Okay. Tell me, what is the answer? 2 into 10 to the power 8. देखते हैं यार. 2 into 10 to the power 8. Pragati. Yes, beta. Pragati, you are right. Yes, see. So, here, refractive index of glass is given. Now, we use simple formula, or we can say Snell's law. This is the plane. Okay, light enters from air, so this is the incident ray. Okay, now here angle is not okay, not use the Snell's law, directly apply the formula of velocity of speed and the relation between the refractive index and all na. See, n equal to c upon v, then v equal to c upon n. Okay, this is the basic formula of speed in any medium where the refractive index is n. Putting all the values here, c is the 3 into 10 to the power 8 meter per second, n is the 1 point I think 5 na, 1.5, yes, 1.5 minus 3 by 2, then we get the 2 into 10 to the power 8 meter per second. Okay, tell me, this is clear na? HP, Azmira, Suresh, this is clear? बेटा बताते चलो सारी चीजें क्लियर हो रही हैं नहीं? कोई डाउट है तो आकर डिस्कस करो मुझसे. इफ यू फेसिंग एनी डाउट देन प्लीज डिस्कस विद मी. ओके, बिकॉज दिस इज अ टू वे प्रोसेस ना. नेक्स्ट, दिस इज द सॉल्यूशन यार. ओके, दिस इज द प्रॉपर टाइप, proper solution. See, the refractive index of ice is this. Okay, and the angle of incidence is 30 degree. What will be the angle of refraction? Angle of refraction, and here given sin inverse 0.381 की वैल्यू गिवन है. गिवन sin inverse 0.381 equal to 22.39 डिग्री. ये गिवन है यार. ओके, रॉकी लोकी रोकी. ओके, रॉकी, टेल मी द आंसर ऑफ दैट क्वेश्चन. Here value is given, okay, because calculator is not allowed na in BSNL exam. So that then simple question are asked, not big calculation. Okay, basic. Tell me beta. The refractive index of the ice and angle of incidence is, what will the angle of the refraction means? Okay, ice, what is the, okay, refractive index of ice. Okay, and the angle of incidence is 30 degree. What will the angle of refraction? See beta. Okay, see, this is the solution. Given data, refractive index of phi is this, angle of incidence 30 degree. So sin I upon sin R equal to constant. Here we incident angle given, R is not given. Constant means refractive index. Okay, 1.31. Apply the formula and sin R equal to this, R equal to sin inverse of this, and this value is given na 0.281 or 381 value given na 381 and 22.39. That is why angle of incidence is 22.39. This is the second question. Sir, light entering from air. Yes beta, yes, assume always. If any medium is not mentioned na, you assume air. Okay, by default. Okay Anubhav, next question. The refractive index of crown glass is 1.52 and the velocity of light is this. What will be the speed of light in the crown glass? This is the simple यार. Okay, speed बतानी है आपको कहाँ? In the medium where the refractive index is 1.52, or we can say speed of light in the crown glass. If we want to find speed of light in any medium, then refractive index of that particular medium is given. Otherwise, we not find the speed of light in a particular medium. Okay, try this. Tell me beta, this is clear or not? What is the answer? What is the answer? N equal to C upon V, na? N equal to C upon V, V equal to C upon N. Putting the value of N, get the result. This is the data, yaar. ठीक है, N और mu equal to C upon V. Mu और N both are the symbol of refractive index. Putting the values, we get 1.97 into 10 to the power 8. Yes, Rocky. Yes. Now tell me up to here. Any doubt? Refraction is clear. Okay. If you face any difficulty, then please discuss with me. Okay. Tell me. This is clear, na? And speed and all are clear or not? अगर किसी बच्चे को ज्यादा स्पीड लग रही है तो वो बोल सकता है, कम लग रही है तब भी बोल सकता है. यस अनुभव, अभी बता रहा हूं ना बेटा. यस सी. अनुभव से सर इन टॉपिक से एग्जाम में क्वेश्चन आएंगे. बेटा एक्चुअली टोटल इंटरनल रिफ्लेक्शन समझाने के लिए मुझे ये बताना पड़ा है. अब मैं चाह रहा हूं ना उस पॉइंट पर. देखो अभी जरा आप कैसे मजा आता है आपको. देखो अनुभव, कॉन्सेप्ट of total internal reflection. Here we discuss only in short way because our next lecture dedicated to total internal reflection. See, here we consider a hypothetical case. This is the transparent medium. This is not the straight line. This is the transparent medium. Okay. Then this is the incident ray like that. Here we assume medium. This is the medium 1 and this is the medium 2. Okay, see. And this is the normal. This is the angle of I. Okay. Here we assume this is the here medium refractive index N1. Here refractive index N2. Okay. And we assume N1 is greater than N2. N1 is greater than N2. Then when light travels from denser to N1, yes, denser to redder medium, then this refracted ray bend towards the normal or away from the normal? Away from the normal. The light move like that. And this is the angle of reflection R. Okay, this is clear? This is clear now? Now, consider an example. If we increase the value of I, increasing means if we like this is the I, if we increase the value of I like that, this, when we increase the value of I, then R also increase. Okay, then R look like this. If we further increase the value of I like that, then R also increase like that. Okay, then after we also increase the value of I, this is the further, then at a particular angle of I, this refracted line parallel to the plane. And here this R is 0 or 90 degree. Tell me beta. At a particular, when we increasing the value of I, at a particular angle of I, R angle is the 90 degree na? Okay. Value of I at which R equal to 90 degree is called critical angle. Critical angle means जिस I पर ये R 90 degree, R means angle between the normal and the refracted ray na. Okay, at a particular angle of I, this R become 90 degree. This particular angle, that is particular value of I, is said to be critical angle. Okay, Anubhav, this is clear na? Tell me, Anubhav, Pratibha, Azmira, tell me, this is clear? Yes. Now next, if this is not clear, then please thumbs up and come on audio feature. Okay, next, see. Like this is the our another case. See, this is the oh no. Here we assume incident ray like this. This is the point of incidence, means this, and this is the normal, and this is the plane. See, and this is the refracted ray. Refracted ray. So we can say this is the angle, critical angle, or we can say IC. Because if this is the critical, then this refracted rays parallel to plane, or we can say perpendicular to normal. Here we discuss now. Now, our interest in that, we further increase the value of I, means greater than the critical angle. See, if we further increase the value of I, means above the critical value, then this light rays, this angle also increase like that. Okay? Means if light enters from denser to rarer medium, then at a particular value of angle, at a particular angle of incident, or at a particular value of I, refracted rays parallel to plane, this particular angle is said to be critical angle. If light enters denser to rarer above the critical angle, then refracted rays completely bounce back, and this is said to be total internal reflection. But tell me, this is clear or not? And this is be discussed in next class also. Here we discuss only brief view, because Anubhav Negi tell me, sir, इस टॉपिक से क्वेश्चंस आएंगे क्या? बट बेटा अगर मैं यहीं से स्टार्ट करता टोटल इंटरनल रिफ्लेक्शन से, आपको रिफ्लेक्शन नहीं पता होता, रिफ्रैक्शन नहीं पता होता, तो कैसे कर पाते बताओ? टेल मी अनुभव नेगी. हिंदी में बताओ, बता दो ये लास्ट वाला ग्राफ. बेटा ये बताया मैंने, क्रिटिकल एंगल क्या पहले ये बताओ. मैं हिंदी में बता रहा हूं अनुभव नेगी के लिए, ठीक है. अगर ये क्रिटिकल एंगल क्या मतलब वो आई जिस पर ये आर जो है ना, ये जो आर है मींस यहां नॉर्मल से और रिफ्रैक्टेड रे के बीच में एंगल 90 डिग्री हो जाए, या मैं कह सकता हूं प्लेन के पैरेलल हो जाए रिफ्रैक्टेड रे. ठीक है बेटा. अगर मैं क्रिटिकल एंगल से फर्दर, मान लो ये क्रिटिकल एंगल आ गया, ये वाला क्रिटिकल एंगल है बेटा, ये एंगल क्रिटिकल है, लेकिन फर्दर मैं इंक्रीज कर रहा हूं आई की वैल्यू मींस इंसिडेंट एंगल की, तो ये वाली रेस किधर बेंड होगी बेटा? अब ये एंगल और बढ़ेगा ना, और बढ़ेगा तो फिर इधर आ जाएगी लाइन, तो जिस मीडियम से जा रही थी उसी मीडियम में वापस आ गई ना. दैट इज टोटल इंटरनल रिफ्लेक्शन ना. टेल मी अनुभव नेगी. अच्छा सर, सर्वज्ञ. नाउ व्हाट इज द कॉन्सेप्ट of that in the optical fiber? See, this is the core of optical fiber. This is the first layer, that is cladding. This is the core and this is the cladding. And this is we discuss in the next class also. Here we discuss only brief view. See, if light rays, but in core light is travels only in core. See, here refractive index n2, and here in n2, because this is also cladding na, and this is the core having the refractive index n1, and core having the higher refractive index is as compared to cladding. Means we can say core is the denser and cladding is the rarer medium. When light travels like that, then this is the normal, this is the normal. Okay, this is the normal, and this is the angle of incident, and this I may greater than the critical angle, so that this incident ray bounce back like that, and again we draw the normal, and this angle make above the critical angle, then this like that, and this is also make greater than the critical angle, this light like that, and this is also greater than this like that. Okay, this is the light. बेटा इसके अंदर ही फ्लो प्रोपेगेट कर पाएगी. Light travels in the core only because it works on the total internal reflection. If we start from this particular theory or this particular topic, then you can't understand the concept of critical angle and all. Okay, see beta, this is understand or not? Tell me beta, this is clear ना? और नेक्स्ट लेक्चर में नेक्स्ट लेक्चर में इसी को प्रॉपर वे में मैं पूरा स्लाइड बना के एमसीक्यूज के साथ में कवर करूंगा. In our next class, we discussed similar topic, that is total internal reflection, construction of core structure, cladding core, jacket buffer and all. And what is the MCQs based on that particular topic we discussed in the next lecture. Okay.